You've probably heard that CERN could open a portal or create a black hole that swallows the Earth. Millions of people still believe it. But if that were true, why did the very machine supposedly destined to destroy us just shut down in complete silence, with no explosion, no accident? The real truth behind this shutdown is more unsettling than any doomsday theory. On June 29, 2026, the Large Hadron Collider went completely dark. 18 years of collisions, of particles traveling nearly at the speed of light inside a 27-kilometer circular tunnel buried 100 meters beneath the border of France and Switzerland, ended in a matter of hours. There was no alarm. There was no evacuation, just a group of physicists and engineers watching the most powerful machine ever built by human hands go quiet after one final brief stretch of high-intensity experiments designed to squeeze out every last drop of data before the shutdown. For 18 years, this tunnel had been one of the busiest places on Earth in terms of raw information. And then, on a single Monday, it went completely still. And this is where the myth falls apart. For almost 2 decades, one theory kept repeating itself across the internet, that CERN, by smashing particles together at these energies, could create a black hole capable of swallowing the entire planet. It sounded terrifying. It sounded scientific. And it was completely false. CERN itself explained it in the simplest way possible. The universe produces more than 10 million LHC-like collisions every single second, completely naturally, in the atmosphere and out in deep space. Cosmic rays, some of them far more energetic than anything the LHC has ever produced, have been slamming into our atmosphere for billions of years. If those collisions were dangerous, the stars, the galaxies, and the Earth itself would no longer exist. The fact that we're still here is literally the proof the myth never had any foundation. Independent safety committees, backed by physicists around the world, reviewed this theory over and over for years, long before the machine was even switched on for the first time. None of them ever found the slightest hint of real danger. And yet the myth never fully died. Every time the LHC ran a new experiment, the same rumors resurfaced, the same warnings spread, the same fear got recycled into a new headline. So if it wasn't fear, why did they shut it down? The answer is almost disappointing in how simple it is, and that's exactly why almost nobody repeats it. They shut it down because it had already done what it could do in its current form, and it needs to become something else. This is what they call Long Shutdown 3, the third extended maintenance pause since the LHC began operating in 2008. There were 2 similar pauses before this one, between 2013 and 2015 and between 2018 and 2022. Each of those earlier shutdowns made the machine a little stronger, a little more precise, a little closer to its true potential. This one, however, is the biggest of them all. CERN's engineers describe it as the most extensive intervention since the machine was first built underground, decades ago. Over the next 4 years, teams of engineers will dismantle 1.2 kilometers of the machine. They'll rip out superconducting magnets, cryogenic cooling systems, and accelerating structures that have been running for almost 2 decades and replace them entirely. It isn't a simple job. Each new magnet has to withstand far higher radiation and thermal loads than the originals, and the entire process happens underground, at temperatures near absolute zero, where a single assembly error could delay the project by months. Liquid helium cooling systems, sections of new cryogenic line, and reinforced detector caverns all have to be installed with a level of precision closer to surgery than construction. The end goal has a name, the High-Luminosity LHC, the High-Luminosity Large Hadron Collider. When it switches back on in 2030, it'll be capable of generating up to 10 times more collisions than the original version. It isn't a new machine, it's the same machine, with its eyes opened much wider. To understand why that matters, you have to go back to the moment that changed everything. On July 4, 2012, the LHC confirmed the existence of the Higgs boson, a particle physicists had predicted nearly 50 years earlier, but had never managed to observe. That discovery wasn't just a headline. It was confirmation that the mechanism giving mass to everything that exists in the universe, including you, was real. News of it spread around the world in hours, and for a brief moment, an underground physics experiment became the biggest story on the planet. After that, the LHC kept working through 3 more full operational runs. It discovered more than 85 new hadron particles. It studied the imbalance between matter and antimatter, one of the great mysteries of why the universe exists at all instead of having annihilated itself in its first instance. It investigated quark-gluon plasma, a form of matter that only existed in the very first fraction of a second after the universe began, and that today can only be recreated, for the briefest of moments, inside that tunnel, at temperatures hotter than the core of the sun. And here's the unsettling part. Every time the LHC answered one question, it opened 10 more. It still doesn't know what dark matter is, that invisible substance that makes up most of the mass in the universe, something no telescope has ever managed to see directly, only inferred from the way it bends light and pulls on galaxies from the shadows. It still hasn't found clear evidence of physics beyond the standard model, the theory that describes all known particles, but that every physicist suspects is incomplete, like a map that explains almost the entire territory except for the most interesting part. The machine pushed humanity right up to the edge of the deepest questions about reality there are, and at that exact moment, they shut it off. Not forever. But for the next 4 years, that edge is going to stay frozen, waiting, while thousands of people work underground to make it sharper. What they're building in its place is, in a lot of ways, more ambitious than the original machine. The new magnets will focus proton beams with far greater precision, using what they call crab cavities, a system designed to tilt the particle beams at the exact angle that maximizes useful collisions. Artificial intelligence systems will select in real time among several billion collisions per second which ones are worth saving and analyzing, discarding the rest in fractions of a microsecond. It's literally teaching a machine to decide which fraction of a second from the birth of the universe deserves to be remembered, and which one is lost forever. Once finished, the upgraded machine is expected to run for roughly another decade, well into the 2040s, collecting more data in its later years than it did in its entire first run combined. And this is where the story stops being just engineering. When Robert Ballard found the wreck of the Titanic in 1985, the first thing he felt wasn't celebration, it was the weight of standing in front of something far bigger than himself. Something similar happens with the LHC, though in reverse. There's no grave here. There's a deliberate human pause in the middle of the most ambitious search science has ever attempted, understanding literally what everything is made of. Thousands of scientists from dozens of countries, many of whom have probably never met in person, are coordinating this shutdown like a single organism working toward one shared goal, following blueprints written years in advance, down to the millimeter. CERN's Director General put it in a way that sounds almost contradictory, but isn't. He said this is an opportunity to explore the universe in a way they've never been able to before. Shutting down the most powerful machine ever built, at the exact moment it was getting close to the deepest answers, isn't a defeat. It's how real science moves forward, by stopping, rebuilding, and starting again with sharper eyes than before. There are even plans, still in the design phase, for an even bigger collider that could one day replace this one entirely. A machine so large it would make the current tunnel look modest by comparison. The LHC, for all its greatness, is already starting to look like a stepping stone towards something more. So the next time someone tells you CERN is going to open a portal or destroy the world, you can tell them the truth. They didn't shut it down out of fear. They shut it down because, after 18 years and a discovery that redefined modern physics, they still hadn't finished asking the most important question of all.
And in 2030, when that machine wakes up again with 10 times the power it ever had, it'll be asking the same question all of us have at some point asked while looking up at the night sky. What are we actually made of? You and everything around you.